Hello everyone. We're taking a look at the 2.15 lesson, and here's our summary, what we're talking about in this lesson. So it says looking at solutions to two variable inequalities on a graph can help us make sense of different situations. Oop, hold on, something's popping up. Go away. Okay. Here's an example. Angel's family makes $4 per pound of strawberries and $3 per pound of plums that they sell. The inequality 4s plus 3p is greater than or equal to 300 represents the pounds of strawberries, s, and the pounds of plums, p, that Angel's family needs to sell to meet their goal of at least $300, right? It can be greater than 300, but that's their minimum. To determine the solutions to the inequality, graph the corresponding equation, which they did. That's our blue line. Decide whether the points on the line will reach the goal by looking at the original inequality, which, since it is greater than or equal to, it's going to be a solid line. Points on the line are also solutions. And then they tested this point 50, 60 and got a true statement. So the solution is shaded above, which makes sense because it was greater than, so we're going to shade above. So any combinations of strawberries and plums in the shaded region would give them at least their goal or more. But not all solutions to the inequality make sense. For example, there's this point 90, negative 20. That would make the inequality true, but we can't sell negative 20 plums. So we don't want to deal with negative numbers. In some situations, it's not going to make sense for the problem. So we just want to be mindful about that. Okay. I'm going to zoom in here. Okay. Here's an inequality. 2y minus x is greater than 1. Select all the points that are solutions to this inequality. Okay, so first of all, we notice that it's the greater than symbol. So this line is going to be dashed, which means points that are on the line are not solutions. So these points, which is negative 1, 0, is definitely not a solution, and 0, 0.5 is not a solution. Now, we're either going to be shading above or below this line. We see 2 points above, 1 point below. So I'm going to test this point here because it's positive numbers. I love positive numbers, which is 9, 6. So 9, 6, if x is 9 and y is 6, we have 2 times 6 minus 9 is greater than 1. 2 times 6 is 12. 12 minus 9 is 3, and 3 is greater than 1, so we're going to be shading above here. So that's 9, 6, and also this point down here at negative 7, negative 2. Okay, so we know that it's going to be above the graph, and then we want to make that line dashed, like I was saying before, because it's just greater than. And there we go. Now it's graphed. Beautiful. Let's go ahead to the next slide. Jasmine says that 3, 10 is a solution. Is she correct? So let's take a look. We have negative 2x plus 4y is less than 15. And we're dealing with this point where x is 3 and y is 10. Alphabetical order, x, y, x always comes first. So we have negative 2 times 3 plus 4 times 10 is less than 15. Negative 2 times 3 is negative 6, and 4 times 10 is 40. Negative 6 plus 40 is 34. And is that less than 15? No. This is false. So we're going to click no, and we can either show it, you can write work shown on whiteboard, or you can explain how you know in this box here. And when you're all set, push ahead to the next slide. Mia is buying snacks for a movie night with her friends. Her budget is $60, so she cannot spend more than $60. A package of snacks mix costs $5. A package of popcorn is $2.50. Write an inequality that represents all the snacks that Mia can buy for $60 or less. So we have S is representing the number of snack mixes, and P is the number of popcorn package. So each snack mix is $5. So we have 5 times S to get the total price of all the snack mixes, plus each popcorn is $2.50 times P, and $60 or less is the budget. So we want that to be less than or equal to $60. Beautiful. So we have 5S plus 250p, and then we want to select less than or equal to 60 and hit submit. So it can be equal to 60 or it can be less than 60. That's our limit. Next slide. Alrighty, problem 5. The functions, cute, are looking into one more venue for their charity concerts. The depot charges $300 per concert and tickets are $20 each. The functions want to raise at least $2,000, and the graph here shows the solution set of negative 300C plus 20T greater than or equal to 2,000. So they have to pay $300 per concert. So that's why we have that negative 300C. And then they're charging $20 for the tickets, so that's our 20T. And they want that to be bigger than or equal to 2,000. So any point in this shaded area is going to be a solution. Or it could also be on the line because it's a solid line. So you're going to find a point that's in that solution set and enter it as a coordinate onto the slide here. And when you're all set, we are going to go to slide 6. So same information here. It says if the functions have 4 concerts and sell 200 tickets, will they reach their goal? So what this is saying is that C would be equal to 4 for the 4 concerts, and T would be equal to 200 because they sold 200 tickets. So looking at the graph, we could go to, this is a point, right? 4, 20, where C is 4, T is 20. So here's 4 and here's 20. So that is definitely not in the shaded area. So we can say that we looked at that point, graphed it, and it is not in our solution region, so it will not reach their goal. Beautiful. And we could also plug this into our inequality by doing negative 300 times 4 plus 20, how many tickets was it? 200? Oh, I wrote the point wrong. Ha, good thing I checked that. So wait, it's 200, not 20. So, my bad. Wait, let me look. So 4, 200. Oh yeah, that's in the goal. It's right here. Whoopsies. That is in the solution set. I missed a 0. So, yeah, it's in the purple shaded area, so it will totally work. If we plug it in over here, 20 times 200, they'll make $2,800. And they wanted to make at least 2,000. So you'll see that it's a true statement because it's in the solution set. Beautiful. Okay, next slide. Aditi's soccer team is selling bags of trail mix for $3 and cups of lemonade for $2 to make a profit. They want to earn more than $120. Which inequality describes all the ways that the soccer team can make a profit? So we have the amount of money that it is for a trail mix, which is $3. And we're going to times that by B, which is our number of bags of trail mix, plus $2 for each cup of lemonade, 2C. So that's going to get us the total amount of money that they're making. And they want to make more than 120. So it's going to be greater than 120. There we go. 3B plus 2C greater than 120. Perfect. Slide 8. Same soccer team. We have our inequality. There's our inequality modeled. Graph all the solutions to the inequality. So let's pick a point. And if we pick the point 0, 0, we can even kind of think about this out loud. If they sell 0 trail mix and 0 lemonade, are they going to make $120? Definitely not. They're not going to make any money, right? 3 times 0 plus 2 times 0 is just 0 plus 0, which is 0, which is definitely not greater than 120. So we're going to want to shade above. And since it is greater than, just greater than, we want to do a dashed line. So make sure to click that line and make it dashed. And then you're going to just explain how we got that and put that in your own words. Slide 9 says the graph shows the solution set to the inequality. Select all the inequalities that produce this solution set. Well, we see that it's dashed. So it definitely cannot be this one because it has the or equal to. So that's just good to know. Let's see. We also see that this line is a negative slope. So whatever's in front of the x term has to be negative. Like this is a negative 1.5x, so that's good. So this one is a positive 1.5x. That's not going to work. This second one, or third one, will work because if we solve for y by subtracting 1.5x from both sides, we get y is greater than negative 1.5x minus 2. So this is actually the same as this one. Those two are actually the same. So the only difference between these now is whether it's less than or greater than. So this is shaded above the line. So that's going to be greater. So these two are going to be our options, I would say. And if we wanted to plug in a point to make sure we're correct, we could plug in 0, 0, because that is in our solution set. Is 0 greater than negative 1.5 times 0 minus 2? This is 0 minus 2, which is negative 2, which is correct. So those two are going to be our solutions. On this slide, for the next one, I want you to do this on your own, creating an inequality. So think about where's the boundary point, which way are we shading, is it filled in or is it open? So what symbol are we going to use? And then lastly, click and drag to graph all the solutions to the absolute value of x plus 2 is less than 3. So remember when we see a plus in here, this is x minus a negative 2. So the distance from negative 2 is less than